In this video, we are going to discuss about our 12th experiment. So that is design and simulate simple 5 transistor differential amplifier. So we have to design our differential amplifier which has to be which consists of only 5 transistors. So we have to analyze the gain, bandwidth and CMRR using this schematic simulations. Okay, so for this differential amplifier we are going to first draw the common mode, so which means only a single input has to be provided. So here as a single ended input, both our NMOS at the uh, down section are connected together with our single input N in, then and output has to be taken from the single ended mode, not in the double ended, that is balanced output. So this is our unbalanced output. So since it is a 5 transistor differential amplifier, so we have to take the output from the unbalanced one. So next our another one transistor is our biased transistor. So in order to give a bias input, we have to place the NMOS at the drain of both NMOS. So we have to connect the gate terminals of both the PMOS, also the gate terminals of both the NMOS. So in the gate terminal of NMOS, we are going to give the input, and in the gate terminal of PMOS, we have to connect it together. So next thing is we have to analyze the AC analysis curve. So for that, I have given the SPICE command as print voltage AC magnitude. So also we have to be concerned that while analyzing the AC performance of a circuit, we should give the input in terms of AC. So for AC, the magnitude I have given as 5, and VDC I have given as 5 volt. So we can save this one. So as usual procedure only, and we have to ensure that our SPICE simulation commands are properly selected. So in general, we have to choose the library files, then we have to choose the analysis. So since we are going to check the AC analysis, we have to ensure that it is check marked. Then we have to give the frequency range, then click OK. So once you check it, you can save this one and you can run the file. See, now our design is running. So you can check, this is the AC analysis curve for our 5 transistor differential amplifier using common mode. So next thing is we can measure the gain value. So just by we can delete the SPICE command and we can go for measure AC gain option. So it is available in our SPICE command. So here in our library, choose SPICE command. The options available within the SPICE commands will get open. Then go for this option, AC measure gain. So we can go and play, we can select and place it here. You can give escape, okay, give save, then you can run again. So it will be available in our tSpice file. So this is the output file. Here you can check the gain value for our 5 transistor differential amplifier using common mode. So next thing is we have to verify the operation of our differential amplifiers, that is common mode differential amplifier. So for that we have to provide a DC input. So I'm going to change the input to DC. So in the master cell you have to choose the option of DC. So the master interface is here. Go for the option of DC and ensure it is 5 volt. So it is, sorry, not DC, we have to give the answer in terms of input in terms of bit files. So that is our pulse files, and you can change the pattern even. So it will be available here. Yeah, it is here. You can change the pattern here. So I'm going to use alternatives of zeros and ones. So you can click that one and save. And another important thing is we are going to analyze the transient analysis. So we have to change that in our setup also. So go for setup, click SPICE simulation, and this time we are not going to check the AC analysis. So uncheck it and go for choosing the option of transient/Fourier analysis. So ensure the proper timing, start time and maximum time is given, and click OK. And what you have to do is we have to plot the graph. So for plotting we can go for SPICE commands and choose the option of print voltage. So it is here. So at the output section I can place one print voltage, and at the input section also I can place one in print voltage. So ensure that now for our transient analysis we have changed our input. So for our AC analysis we have to give an AC input. Also in setup simulations command we have to set the AC analysis unchecked. So be careful in it. So we can run this one. So yeah, this is our curve. So we can, this is our W waveform window. So in this window we can go for this expand short option, since our three print voltages we kept in our circuit. So that is, so one is at the V bias end, another one is at the input end, another one it is output end. So all the three ends we have to see at a time. So our waveform is like this. We can expand this chart by clicking the expand chart. So now we can check. So in the right corner you will find the corresponding chart. So this is the graph. The first graph is for our V bias, which means DC voltage. A DC constant 5 volt voltage is being given at our bias section. So next at our input section, that is our V in, we have given an alternative pattern of zeros and ones. So 0, 1, 0, 1, 0, 1. So next we can go for our output. So important on term. So here you can check. So once our input is 0, we can get here as 5 volt, that is 1, digital value is 1. So once our voltage is 5 volt, here we have got the answer as 0 volt. So which indicates this is a invert operation. So which satisfies the principle behind our common mode of differential amplifier. So that is, if you are giving an waveform in our input, that will be inverted in our output. That is the principle behind our common mode. So next thing what you have to do is we have to draw the circuit for our differential mode. So this is our common mode operation. Now I am going to draw the circuit for my differential mode. So for that, so already I have created a new file diff. So under this you can just go for creating a new cell alone. So go click new view. A view will be open. So the design will be under diff only. That is our differential amplifier only. So now in the cell 1 I am going to draw the differential mode of differential amplifier. So click, ensure it is inside schematic and click OK. Now our new window got open. So next one thing we have to place our components. So we need 2 PMOS and 3 NMOS. So devices, under the devices our mass transistors will be available. So I am going to highlight the devices and choose the option of PMOS first. So I can choose the PMOS and select. So here ensure the interface should be in PMOS 3. So we need PMOS 3, and also we need 2 number of PMOS. So I can place 2. And next thing is we have to place our NMOS. So here in the devices you can select the NMOS and you can click the option of 3 and place it here. And another one NMOS. So since it is a 5 transistor differential amplifier, we need 3 NMOS and 2 PMOS. So next important thing is we have to connect these circuits in terms of our differential mode. So for that I am going to rotate my circuit. Okay. So we need to rotate the circuit since okay. Once we rotate, we can go for the option of flip. So we have to flip this one. So ensure it is highlighted and go for here, flip horizontal or vertical. So since this is my PMOS structure, I need to connect in differential mode. So I have rotated the structure, but we have to ensure whether our which terminal is present at the at the output and input session. So in all the PMOS cases, we will connect our source terminal to our VDD. So if we want to connect this two pair of transistors, here the drain terminal at the down end and the source terminal at the VDD. So we have to flip this one. So for that, go for draw and choose the option of flip. There you can go for flip vertical. So which means our transistor got flipped. So next thing what I have to do is I can move it here. Can do. So we need to select PMOS 3 here and click R to make the transistor move. Okay, then click escape and go to draws and choose flip vertical. So now it is correct. So our source terminal it has the upper position. Now we can easily connect our both sources using our VDD. So for that I am going to make it connection. So I am going to connect the source terminals of both my PMOS and then I can connect it with my NMOS. Okay, click escape. Next thing what we have to do is we have to combine the gate terminal of both the PMOS. So that's why we perform flipped and rotation and all. So here you have to do this one, and later we have to connect the endpoint to with our PMOS. So before that I can connect the terminals with my NMOS. Then we have to combine both the drain terminal of our NMOS and I also ensure that here our transistor is placed properly. Yeah, it's placed properly. You can check. Now the wire has become blue color, so you can check that also. And after this connection we have to establish another one important connection, that is our differential mode connection. So we are going to connect the both ends of gate here, and please be ensured that we have to place our output port here, and we have to place our input separately. That is for our input 1 is at our input NMOS 1 and input 2 it is at our NMOS 2. So we can flip that one, and again we will do this. Okay, go for draw, go for flip vertical. So we have to delete this one. Okay, we can give the input by this way. So I am making wire connections to provide inputs to each pin. So next for bias also we need to give bias transistor, also we need to give input. So there also I have kept the connections. So we can now place the ports, that is my input port. So I can place it here, and I have to name this one as in 1. Since we are providing two inputs, I'm going to name this one as in 1, and the next thing is my input 2. So I can place it at the second NMOS and give the value as in 2, and the next input I need is bias. So for that I can name it as V bias. So now these three inputs we have placed it in our circuit. We have to define it. So for that we can define it separately. So this is our input 1. I'm going to define it. So I can place it here, input 1. Next is our input 2. I have to define my input 2. So I can place it here. input 2. Next is our V bias. So we have to define our V bias also. We can place here and give the name as V bias. So next is important one is VDD. We need VDD. So for that we can go for spice elements. Sorry, inside the MISC we can find the VDD and ground as well. So select VDD and place it at the end point here, and another VDD also we need for defining. So once it is placed we can give escape, then choose ground. Ground is available here. We need to place ground for our all these sources which we are going to define later. So I can place the ground, can click close. So now the thing missing is our output port. So choose the output port and place it here and click OK. So next thing is we have to place our spice elements, that is source, voltage source. First DC voltage source I need for my VDD. So define my VDD. So next is for my input 1, input 2 and input 3. Okay, after this we can go for defining the nature of our input. So I can place the ground properly and here also. Okay, now give escape. So for VDD a constant of DC voltage must be given, and for V1, that is our input 1, we have to give the pulse voltage. So for that I'm going to select that particular voltage source, and in our master interface I have to change it to bit, and once it is changed we can give our own pattern. So that is available here for addition. So I am going to give alternatives of 1. Okay, then next for my input 2 also the same thing I have to do, that is I have to convert it into bit pulse. So go for that, and here the pulse will be as like it. Next is bias can be at the bias voltage can be at the DC voltage, so there is no problem in changing it. So next thing what we have to do is we have to place the spice commands. So in order to see our output, so go for searching this print voltage command. So we can place print voltage at our input, at our output, and also at our bias. So click escape. So once choose this one and okay. Okay, now we have to save this file and go for setup, simulation, and in general cases we have to select for our library files. So this is the library file. So once you open this one, then go to the end of that generic 0.25 and give some space, game space, and type capital TT, and then choose for analysis. So I'm going to perform transient and Fourier analysis. So 100 nanosecond to 10 nanosecond period. So give OK, and we can save this one. We can run. So since only one input voltage is displaying, so for our input 2 we hadn't placed the spice command. So I am going to place at the input 2 also. So give escape. Now save and again run. So ensure what are all the ports we have to view, and now the output chart opens. This is the single chart which is having all the spice command values. That is, we placed our spice command print voltage at our input, output, and another second input as well as bias. So I'm going to split the window. So now we can check. So at the right corner you can check. So the bottom of the graph, it is our input 1 and this is our input 2. So input 1 and input 2 are this is the differential amplified value, that is our Vout value, and this is our bias value. So this is DC, direct DC current, sorry, DC voltage. So this is our V in 1 and V in 2, sorry, V in 1, V in 2 and V out. So this is our output for our 5 transistor differential amplifier using differential mode of operation. So next thing what we have to verify is we have to verify the value of our AC voltage, that is our AC analysis. So for that we have to change our inputs. Okay, for input 1 I am going to change it to AC. So AC convert பண்றேன். Then I have to give some value for its magnitude. So I'm going to give us 5 and this also. So next this one also I'm going to change it into AC analysis. So next thing we have to give the value for our magnitude. So magnitude value is 1. So let it be. So next thing what we have to do is we have to go for placing the spice command. So this time we are going to print the voltage in terms of our dp magnitude. So go for choosing AC magnitude and place it here. So next is we have to save this one, and please ensure we have to change the analysis now because we are going to see the AC analysis. So for that we have changed the input to AC. Also we have to change the spice command also. So go for the AC analysis. So uncheck this one, and we have to give the start frequency and stop frequency. I'm going to give 90,000 K, and for this one duplicate, and this is my 100. Okay, we can save this one and we can try. So I think some error. We can check out the error and come back. So initially what was the mistake we did is we hadn't assigned the magnitude and VDC value for our input 2, that is the terminal NMOS 2 is connected. So there we have assigned the value as there now I have assigned as 2 and magnitude as 2 and VDC as 2 volt. So in our input 1 magnitude as 5 and VDC as 5 volt. So now we can check the results. So just to save this one and click run simulation. So here we can get the output. So this is our AC analysis curve for our differential mode of 5 transistor differential amplifier. So here after this we can measure the gain by means of circuit. So by placing the spice command of AC measure gain, you can easily measure the gain, and you can go for this AC measure gain and choose here, hit escape, hit save, and then run. So now you have to check the file, you see the gain value in our spice command. So this is the gain. So using the waveform also we can easily calculate the gain, and using the gain value you can calculate the CMRR value. So this is how we have to design and simulate 5 transistor differential amplifiers, and we have to check the verification operation using common mode as well as the differential mode, and later we have to we have to perform EC analysis for both the circuits. So thank you.